everyone. Hello everyone. Myself Abhineshri Swarna. Today we are going to discuss about machine learning. We are diving into the fascinating world of machine learning, the technology where meets the behind smart apps, self-driving cars, and even Netflix recommendations. What is machine learning? Machine learning it is a branch of artificial intelligence where computer learn from data to make decisions. For example, if you show a mission lot of photos of cats and dogs, it can learn to tell the difference between them. ML models is used to find the patterns in data and use those patterns to make predictions or decisions, like predicting weather forecast or detecting the spams in emails. And coming to the next topic, in machine learning we have four types of machine learning is four: supervised, unsupervised, and semi supervised, and reinforcement learning. But we used only mainly three types of machine learnings, that are supervised and unsupervised and reinforcement learning. Then supervised learning. Supervised learning can take an example of classroom. This is like a teacher helping a student. The data comes with answers, means it is used to label the data, it show only data. Whether the supervisor learning is takes the inputs as well as outputs. Examples of email spam detection: the machine trained the emails labeled as spam or not spam. Next topic, unsupervised learning. In unsupervised learning, we can show that the data is unlabeled, only we can give the input but we didn't get the output. In supervised learning, we can say that, for example, we can take the bunch of basket of fruits. In that basket, we contain apples, bananas, as well as grapes. And there, when we are training to the machine, the input itself is given as apples, bananas, and grapes, and the output also mentioned there. So it is called as table data. It is called supervised learning. In the same way, unsupervised learning, we should give only input. It didn't give output, and we can predict the output. And coming to the supervised learning, this is the mix of both. We give the mission a small amount of labeled data and a lot of unlabeled data. Think of it like giving the hints and asking mission to figure out of the rest. Next, fourth one is the reinforcement learning. It is the action reaction formula. When we give it here, this is like a training a dog. The machine learns by the trial and error method, getting rewards or penalties. For example, self-driving cars. Self-driving cars can learn to drive better by getting rewards for safe moves and penalties for mistakes. And coming to the machine learning models. These are the popular machine learning models: linear models, tree based models, and intent based models. Logistic regression, support vector missions or belongs to the linear models. Logistic regression is simply known as it can predict the outcomes as yes or no. Support vector mission, it finds the best separate line. It is used to separate the data by using a hyperline. This hyperline is known as the best line. And coming to the next supervised learning model is decision trees. Decision trees or random trees, both are same. Decision trees and random trees are random forest are. These are like flow charts that can help make decisions. K nearest neighbor is the another type of supervised machine learning model. K nearest neighbor is used to predict the data which are nearby the line. And coming to the unsupervised learning model. These are the unsupervised learning models. The unsupervised learning models are also furtherly classified into different types like K-means clustering, PCA, and anomaly detection. K-means clustering. It is also known as group of similar things together. For example, we can take a class. Here there are two groups, girls and boys. Girls are forming into the one group and boys are forming into one group. These two groups, these two are similar groups, and these two groups are making into together. And PCA. PCA is known as principal component analysis. It is used to reduce the data size for a easy visualization. Visualization is the another topic in machine learning. Visualization means it is used to visualize the data which we are predicting in machine learning. or which we are detecting in the machine learning. Anomaly detection. Anomaly detection means it can catch the outliers like fraud in credit cards. For example, nowadays we are seeing a lot of frauds in banking sectors. We are facing so many fraud detection cases. In that cases, it can use it to identify the anomaly. It can identify by using the anomaly detection. Reinforcement learning is one of the type in machine learning. As previously we said that reinforcement learning is used to prevent the penalties and rewards. By example, self-driving cars. Self-driving cars, if it go in a correct and safe way, it will get the rewards. Or else it will make any mistake or it will make an accident, it will get the penalties. And here we can use the two main algorithms which include Q-learning and deep Q-learning networks. In any algorithm of machine learning, we can use these steps to perform the or to predict or to detect the. There are mainly five steps. First, we have to select the model. First, we have to take the algorithm and we have to prepare the data. And third, we have to train the model. And fourth step, we have to test it. Learning machine learning model. Evaluation matrices for machine learning models. There are two types of matrices, classification matrix and regression matrix. In classification matrix, we use it that how often it's right or precision and recall. It means in classification matrix, we can get the a proportion of correct prediction. In regression, we didn't. Here we can use that F1 square and AUC. F1 square and AUC are used for deeper analysis of the evaluation matrices. Mean squared error or means absolute error are used for to find the absolute difference or penalizing the large errors more. For these purposes, we can use this evaluation of matrices in machine learning models. Coming to the real world applications of machine learning, image recognition, recommendation systems, financial forecasting, natural language processing. In image recognition means nowadays we are all are using the smartphones. By using our face recognition only, we can unlock our mobiles, or else we can't. So it is the best example of ML models. And next one is the recommendation systems like YouTube or Spotify. It can for example, take YouTube. I want to search about machine learning videos and I searched it there. Furtherly, when I open the YouTube, it will show the same recommendations. It is the perfect example for recommendations. And coming to the financial forecasting. Forecasting means predicting the stock market values or stock market prices. And NLP means it is used to prepare the chartboards, translators, or Google translations, voice translators, or etc. The challenge is what we have faced in the machine learning. Machine learning is powerful but not perfect, yes, which includes these kind of challenges like data quality, bias and fairness, interpretability, computational cost. Data quality means whether it is the bad data, we give the bad results. Whether it's good data, we can get the good results. So what what the algorithm is performing here when we are using the machine learning algorithm, must and should it should be a good data. Otherwise, we can't get the good results. Bias and fairness means some models may unintentionally be unfair. Interpretability, some models are like black boxes. So for in these kind of outcomes, when some models are like some models are like computational cost, they can be expensive to train. The models which we are used to train are very comprehensive or very expensive by at cost. And the future of ML. Machine learning is evolving fast. We are seeing smarter models, ethical AI, and more automation from health to education to entertainment. ML is transforming our world.